Hi, my name is Dan Fu. In this video, I'll be talking about Epoxy, our effort to enable faster model iteration by using pre-trained embeddings without fine-tuning. Our goal in this work was to enable the development of high-quality models that can be iterated on at programmatically interactive speeds, so that someone can train a model, inspect its results, and fix its failure modes in seconds instead of hours or days. In this video, I'll talk about how we take a small step towards this vision by combining ideas from weak supervision with pre-trained embeddings. We'll take a look at some of the theoretical guarantees of our method, and we'll see how well it works in practice. Let's start with the weak supervision part of the story. We build on a line of work in weak supervision called data programming, embodied in systems like Snorkel and Flying Squid. Data programming uses programmatic labeling functions to generate noisy labels for the data instead of relying on hand labels. These labeling functions often do not cover all data points or examples, so data programming uses labeling function votes to train an end model for better overall performance by improving coverage and generalization. But training the end model can be slow, which creates a bottleneck in the iteration process. This is where pre-trained embeddings come into play. Pre-trained embeddings have been effective at reducing training costs through transfer learning, so we were wondering whether we can use them to reduce training costs in our situation. The challenge is that, without fine-tuning, these embeddings are not globally discriminative, and although fine-tuning is much cheaper than training from scratch, it can still take minutes or hours. Our insight with Epoxy was that, although the embeddings aren't globally discriminative, they're still locally informative and can be combined with labeling functions to improve coverage. Instead of using the pre-trained embeddings as features in an end model, we use them to create a distance between points and extend the coverage of our labeling functions. We simply use strategies like nearest neighbor search to extend labeling function coverage to nearby points in the embedding space. In this setup, the labeling functions act as anchor points in the space so that the embeddings don't have to be globally discriminative. And the embeddings help us extend labeling function coverage to points that we would not have gotten otherwise, gaining the coverage and generalization benefits of an end model. Now you might be asking, how well could we expect this to work? We can theoretically characterize how much lift we can get from Epoxy over data programming methods, and show that lift comes down to a trade-off between extending labeling functions more to increase coverage versus extending them too far, which can hurt accuracy and depends on how smooth the embeddings are in the task distribution. Check out our paper for more details about this trade-off, as well as a theoretical framework for examining how Epoxy compares to other models, such as transfer learning. Now let's see how well this works in practice with a spam classification task. The first row of this table shows labeling function performance before training an end model. As you can see, the precision is pretty decent, but recall lags behind. Now if you look at the right side of the screen, we can see a short video of training with Epoxy to improve performance. So here goes, and we're done. The results of this model are shown in the second row on the left. As you can see, Epoxy improves recall by more than 10 points by correctly identifying more positive examples. And it trains in less than a second instead of the minutes or hours it could take to train an end model. These trends hold across 6 NLP and video tasks that we used for evaluation. Epoxy provides 4.1 points of lift on average over using the original labeling functions without training an end model. But perhaps surprisingly, we found that we could come within 0.7 points on average of training an end model over the original labeling function outputs, while training in half a second instead of requiring many expensive rounds of SGD. If you do have time to train an end model, Epoxy can further improve end model performance to achieve new state-of-the-art performance. Thank you for listening today. In this video, we talked about Epoxy, a first step towards faster model iteration with weak supervision and pre-trained embeddings. You can find our paper on arXiv now, and please reach out if you have any questions.